A very warm welcome to everyone. Thank you so much for joining our webinar on Bayesian item response modeling in PyMC. Today, we are joined by Morgan Peel from Alva Labs and Tommy Caprato from PyMC Labs and myself as the host, Thomas Wiki. I wanted to start by just giving a couple of general information about who we are, and then we're going to launch into the discussion presentation. So we are PyMC Labs, the Bayesian consultancy. We are the people who wrote PyMC. Probably that's how most of you got here. If you don't know, it's a probabilistic programming package in Python that allows you to do Bayesian statistical modeling with great flexibility. And we have a really rich, deep team now of Bayesian experts assembled. We call ourselves the Bayesian Avengers. And we basically help companies solve all kinds of problems that they have using PyMC, or just problems where Bayesian modeling is a great fit for. Here are some links. I'm going to post this also in the chat to connect with us and stay up to date of events like this, but also the open source. So if you want to check out PyMC, this is the GitHub, or just pymc.io. We are on LinkedIn, we're on Twitter, YouTube, and here is also the PyMC Lab specific websites. We have that's pymclabs.io, and here's the meetup page, probably how you signed up to this. We also have a Twitter account. Do note that we have a code of conduct that we borrow from PyMC, the open source project, and that we ask everyone to follow. A small other thing, if you're interested in learning more about these methods that we're talking about today, we offer an introductory course through Intuitive Bayes. So check out that, intuitivebayes.com. If you want to learn this without a lot of math, but focused for practitioners. You can also email me directly if you have any questions, or follow me on Twitter. As I mentioned, here are the links for the website of our open source project with documentation and links to resources and everything, and a link to our company's website. And also want to note, we do corporate workshops in addition to what I showed you a slide ago, where we come in and teach you and your staff the amazing powers of Bayesian modeling. So with that, I wanted to just introduce ourselves. So as I already mentioned, I'm Thomas Wiki. I am the co-founder of PyMC Labs and CEO. I'm going to be hosting today. I got started with PyMC in grad school at Brown, had a really good time coding that, and that sort of stayed with me throughout my whole career. So I'm really excited about how the software now is being used by all kinds of companies, including Alva Labs, as we're going to talk about today, to solve applied business problems. And also equally excited about its use in science and academia. So next up, I want to hand over to Morgan to introduce himself, and then hear from Tommy. So Morgan, hello.
Hello, thank you. My name is Morgan Peel. I am head of research and development at Alva Labs, which is a Stockholm-based startup in the recruitment space. My background is I studied a master's in psychology, and then I've been working in organizational psychology for about 10 years. About 2 years working as a data scientist at the Swedish payments provider called Klarna. So I guess my profile is very much a practitioner within psychology/data science.
Fantastic, thank you. And Tommy?
Hello, everybody. Welcome to you all. Well, I'm Tomás Caprato. You can call me Tommy if you want. I'm a statistician from Argentina. My career was in statistics, just because curiosity. I liked math. I still like it, and code. So statistics was a good combination to keep learning about new things. And eventually, I started a PhD in Argentina working in Bayesian statistics, and that's how I ended up knowing PyMC and then Bambi, which is the library I helped with the development. That's what eventually took me to work with PyMC Labs and today's webinar, and knowing Morgan and Alva Labs and helping there.
Fantastic, thank you. So one final note before we get going, talking about the project and everything. This is a Zoom webinar, which is the first time we're trying this. It's a bit different. There's no chat feature. Instead, you have a Q&A if you go to this, and there you can post questions, you can vote on questions, and we're gonna answer them either in chat or take them live. Yeah, so this is basically how you can interact with us. So please, anything you're wondering about, go ahead. But yeah, so this is really the project that we worked on with Alva Labs and helped them develop this item response model. And yeah, so I guess we want to start with what is an IRT and how is it being used at Alva Labs?
I believe that's me. So, okay. I think, yeah, I'm going to start by outlining the talk. I'm going to start by presenting Alva Labs briefly, what we do, who we are. And then I'm going to talk about how we have implemented Bayesian item response theory for our personality test, and some of the challenges that have been emerging over the years. And then I will leave it to Tommy to talk about the solutions that PyMC Labs have proposed. So we are, as I mentioned, a company within the recruitment space. We provide software as a service for organizations that want to use best practices in hiring, basically. Our mission is to make hiring better for everyone. I guess most people listening in have experience from either being candidates in recruitment processes or recruiting themselves. And I'm sure you're aware that there's a lot of subjectivity involved in hiring, lots of bias, potential for bias, and a potential for information overload if you're a recruiter looking at CVs and other information you might have on your candidates. So what we have focused on up until now is to provide psychometric tests, mainly personality and logical ability, and also structured interviews, tools for structured interviews, and coding challenges. And these are things where you get some more structure in your process and also some more objective data points that can inform hiring decisions, basically. And finally, an algorithm to combine these data points and get a summary score. And we are taking some new steps that will make us dive deeper into the machine learning area. So we're hiring for a senior machine learning engineer. If you're interested, feel free to reach out to me. I added the link to the role in this presentation. I guess it will be shared after the talk, so you can access this from there. And I will now present the way our personality test works. So it measures the big 5 personality traits: agreeableness, conscientiousness, extraversion, emotional stability, and openness. And there are 3 subscales for each of these factors, which means that our test comprises of 15 scales in total. And for those of you who have experience in psychology or personality theory, you all know that this is the most widely used model for personality. And that's the reason why we chose this particular model for our test. The way it works is test takers respond to these statements, and then the scores are calculated and presented in a report immediately after the test is completed. So in this example, the first statement, "I care about others," is related to agreeableness, and more specifically, the sub-facet called compassion. So we believe that people who are more compassionate tend to agree to this statement to a larger extent than people who are less so. And the second statement is an example of a question that relates to conscientiousness. I want everything to be perfect. And again, people who are very orderly would be more likely to answer with one of the higher options on this scale. So I'm going to give some brief background to the development of this test. We wanted to provide a really nice candidate experience, to not ask too many questions, focus on the most relevant ones. So we wanted to do adaptive testing to not waste the test taker's time, basically. We also want to provide feedback and results immediately and let candidates own their results and decide which organizations should see the results or not, which is actually something that sets us apart a bit in this space. We strive to have a strong research foundation. As I mentioned, the Big Five model of personality is the most researched personality model out there, proven to predict job performance, especially conscientiousness. We also strive to have accurate and well-calibrated results. My experience is that people tend to view numbers as a truth. And so my ambition has been to live up to that and make results interpretable and sort of relate to a wider population. I'll get into some detail later. We also want to provide continuous improvements to the test, being able to remove questions and add new ones. If we realize that questions don't perform or live up to our standards, we want to be able to take them out. And finally, supporting multiple languages. And a nice way of dealing with all of this is to use item response theory. This is a statistical framework for psychometrics that's been around since the 60s, basically. It's been adopted widely in academia since the 80s. I would say that basically all papers that have been written since then have been about item response theory and not about the previous theory that was used to create tests. However, this industry is actually lagging quite far behind. Most tests that you will interact with still rely on what's called classical test theory, which has its roots in the late 1800s, actually. And some reasons for this low adoption, I believe, is that the computation is a bit more complicated. It's hard to do these calculations by hand. So you really need to use a computer to do the work. There's also some mathematical sophistication involved that I think we might actually lack the required skills to deal with that in this industry. And so what is item response theory then? Well, basically we assume a statistical relationship between person characteristics on the one hand and item characteristics on the other hand, and the observed responses to a test. And you can see a graphical representation of those relationships to the right. This is the simplest possible IRT model where you have one parameter for the item and one parameter for the person. And even in this most simple case, you get some really nice advantages compared to classical test theory. They might not seem very big, but the ability to sort of deal with each item separately actually allows you to assign test takers different items and still be able to come up with a result. So that makes for a really good framework when you want to have, let's say, a large item bank and then show users a subset of that item bank and select items based on what gives most information about that particular person. it also supports this continuous improvements that I mentioned. We're able to couple the items from the score to some extent, which means that we can add new items and remove non-performing items. And none of this is really possible if you use classical test theory. So this has really been making for a good basis for us to do, like, for our workflows and to keep improving our tests, basically. And adaptive testing, I mentioned that we want to serve questions that are relevant. So there are existing algorithms for real-time scoring and item selection that we can use. And this is all targeted the principle that I mentioned, to create the delightful experience for the candidate or the test taker.
Morgan,
so,
maybe we can
yes.
Just take one or two questions.
Yes.
So G Zhang asked, will people fake answers to personality questionnaire, knowing that the company may be looking for?
Yes, this is a common question. So this is called social desirability in the literature. And what it means is that you might want to present yourself in a more favorable way when you're looking for a job than you would otherwise. And so what most studies show is that no matter if there's an incentive to show social desirable answers, there's still a statistical relationship between the results of a personality test and future job performance. So I think, we're being quite pragmatic here. Even though we believe that this exists, that social desirability exists, we can still use the data from a personality test to predict performance. So yeah, but I know that there's a lot of debate in the industry and in academia about how you best deal with this. And our stance has been that we believe that social desirability is a factor. We believe that people do present themselves in a favorable way. But it seems like people who, for example, state that they're very conscientious, that they always finish what they start, they actually tend to do that when they get the job as well. So I guess what I'm saying is that I care less about the truth here, like the true personality, and more about what future behaviors that the test results predict. Did that answer the question?
I think so, yes. And then maybe one other from Jizeng. She is interested in he is interested in knowing the algorithm for combining data points. Do you have a reference for that?
Yes. So I guess we started out, as many companies do in this space, looking at Hunter and Schmidt. There's this article from '98 where these authors combine research from the last 100 years, and they propose I guess it's a linear model where you combine like GMA, which is logical ability basically, with other factors, and then they provide the coefficients for that linear model. So that was our starting point, and then we have extended it. So it's a variant of a linear model, basically, where you can assign weights to different data points, and then it gives you a prediction of how well this person is likely to match the job.
Right.
Were there any other questions?
Okay. There is, but maybe let's keep that one for a little bit later.
Perfect. So I mentioned the structure of the personality test and what we want to achieve. So what we ended up doing is to go with this graded response model, which is, it also has its roots in the 60s, and it was developed for just this type of data where you have Likert type responses. I think that's the way you pronounce it, at least. And so in this model, you have one parameter for the persons. You assume like a one-dimensional latent ability or trait in this case. And then you have a slope parameter alpha for each item. And then for each boundary, which is basically, the threshold when you move from a response of 1 to a response of 2, between 2 and 3, between 3 and 4, and between 4 and 5. So there's a threshold or an intercept parameter for each boundary within each item in this model. And there are some out-of-the-box IRT software out there that you could use to train a GRM model, but it's quite common in this industry to have either small or skewed data sets, and using maximum likelihood or expectation maximization, there's no neat way to deal with that. You sort of assume that the data is randomly drawn from a population you're interested in. And that's one example where I find Bayesian inference to be very useful. You can sort of include that knowledge into your models and add priors to regularize parameters in the model. Let me know if I'm being too technical here, but I've worked with these more standard implementations of IRT software, and I've seen some really crazy values appearing, models blowing up. And I find that using a Bayesian approach really makes it easy to regularize and prevent the model from overfitting to data. And dealing with identifiability issues that you could run into. And finally, there's been a lot of work in the recent years within probabilistic programming. There's like PyMC is an excellent example where you can develop models that fit your needs. You can start out, as we did with the graded response model, and then extend it to, for example, support having multiple language versions of the same items. And then finally, it provides some diagnostics out of the box. So you can get a sense of how well the model is defined, how well it's calibrated, how well the model sort of recovers parameters, and also nice diagnostics about the algorithm itself if you use sampling. So that's what I ended up doing. I implemented this graded response model using PyMC. And so our workflow basically looks like this. We have a database of responses. We run this parameter estimation in PyMC, and then from that we get parameters for the item, the alpha and the kappa parameters that I mentioned previously. And then in our in our production system, we run this adaptive testing process where we observe a response from a user. After each response, we score, we estimate the trait for the individual in real time. And then there's a decision process where we basically look at the posterior uncertainty. And if we have enough certainty in the score, we terminate the test. Otherwise, we use an item selection algorithm to serve another question, and then the loop goes on. And this is not implemented in PyMC. This is we're using grid approximation here in Python or NumPy. So the GRM model is implemented in two places, basically, in the PyMC parameter estimation code base, and also in our production systems.
Morgan, we have
yes.
Another question. which is, I guess, more direct related. So Alex Brewer, I see your question. We're going to get to it a little bit later because it's a bit more advanced. But I want to read Ben Mara's question. Is the person trait supposed to be a measure of a person's performance? If so, how is this quantified for training? If not, on which data is the model trained?
Your sound is a bit off to me. Is it distorted to anybody else?
So you could also just read it in the Q&A, but I'm going to fix my sound.
Right, let's see. So is it Ben's question then? Is the person trait supposed to be a measure of a person's performance? If so, how is this quantified for training? Right, so it's not performance per se. This theta parameter relates to their, let's say, extraversion. So, if somebody agrees with the statement, I am the center of attention, I like to be the center of attention, and you strongly agree to that statement, then we view that as evident that you're quite extroverted. And if we observe a response of 5, then that means that we will assign a higher score on this trait. So it's not performance per se, it's more your level of this trait that we're measuring.
And I would like to add something there. At least the way it helped me to see it. So the question says whether there is something observed or not. And as you said, Morgan, there's nothing observed. So it is more like an latent parameter that you estimate. And that allows you to determine where each person is located in that trait. So it's latent, not observed.
That is a good point. I guess you could see this as unsupervised learning, if you want to use that terminology. We don't have ground truth for these personality traits. Right, so moving on then. Let me see if I can, yes. Right, so some challenges that we've run into in the last years. I think it mostly stems from our data sets growing a lot. We started out with having about 1,000 persons taking the test, and that has grown to about 350,000. And the number of items has also grown by a lot, from about 200 to about 4,000. So as you may understand, this means that our posterior dimensionality has grown by a lot. And what ended up happening was that running Markov chain Monte Carlo took days. And I think, it crashed, possibly due to running out of memory. And variational inference on this model took hours. So that's why we turned to PyMC Labs, because of your world-leading expertise in Bayesian computation and inference and modeling. So the main task for PyMC Labs was to speed up sampling, make it tractable. And I guess maybe it wasn't as outspoken, but for me, it was important to get some external eyes on the model to get some sort of a sanity check, because I had been developing this model in my own head. So if you guys would shout at me or make fun of the choices I made, then that would have been a sign that I did something bad. That hasn't happened, happily. But yeah, so that was another reason for turning to PyMC Labs. And I guess I'll leave the mic to Tommy now.
Yeah, thank you, Morgan, for the wonderful introduction. I don't know if we should answer the questions right now or later. in the very end, we have 2 new questions. What do you think, Thomas?
Well, maybe let's make sure that we get through your stuff, and then we'll do the rest of your Q&A at the end.
Perfect, makes sense. So I'm going to start sharing my screen now. Sorry. Let me know if you can see the slides well.
Yes, we can.
All right. Okay. So let me do something else. This. I think that's better, right?
That's perfect, yeah. And you press L, you get the laser pointer.
Of course. Thank you. So Morgan has been given a background about what Alva Labs is doing and the story behind their graded response model and how and why he reached out to PyMC Labs to help with the model, specifically with speedups and model review / improvements. And I'm going to tell you how we worked in this project, which is going to reveal how we work in many projects, because there are always some commonalities. But the first thing we need to do in this case and all cases is understanding the problem we are facing. Once we understand the problem, or we have a good knowledge, we come up with a plan, how we are going to, what's our workflow going to be to help solving this problem. Then we usually iterate on model specification. It's not that we go straight to the final model in one shot. And once we finished iterating on model specification, we simply delivered the improved model, which is not just a model implemented in code. It is also detailed documentation and the whole story telling how we got from the beginning to the very end. So when the first step is understanding the problem, we need to understand what Alva Labs do, what's their domain, what model they have, how they use the model. And understanding the model is understanding the code and the math behind the model, trying to detect points of improvement. Since this is a very specific topic, item response theory and a graded response model, we also reviewed literature and what other people did. And once we have a basis in terms of the model and the problem, we go to the data. We need to know what's the size of the data, which variables are being measured. We carried out exploratory data analysis at this stage, we usually detect some challenges we are going to have when fitting the model. For example, let's say, what happens if we don't have answers for one of the levels in these questions, in these ordinal responses. And that also helped us to get more familiar with the data generating process, which in this particular problem, it was extremely helpful. And then it's very clear how we're going to help. We're going to provide a model review, reviewing both the math and the code. We want to improve the model. We want to determine if there's something we can change to make the model more realistic and flexible. And of course, one of the main goals of the projects was to make it faster. In this particular case, the workflow we used, the Bayesian workflow we used, consisted first of simulating the data generating process. And I'm going to tell you a little more about that in a moment. Once we got that, we want to model implementation, but always starting very simple to understand the very basics. Then we evaluated the model using parameter recovery studies, and also we evaluated the inference speed. And once we are confident with that very basic model and very basic scenario, we start iterating, expanding the model step by step. So what we did in the data generating process simulation, this was the second thing we did in this project after exploring the data. We developed a Python module that simulates data under similar conditions to the process that generates the data collected at Alva Labs. And what are those conditions? We have multiple people, we have multiple questions, and we have multiple languages. But on top of that, there are other factors we need to consider. Since Alva Labs uses this adaptive testing, not all subjects answer all questions. That means that a given subject is going to answer given 5 questions, and another subject is going to answer perhaps other 5, 6, or 7 questions, or perhaps there's some overlap in the questions they answer. Since there are multiple questions, we usually have different shapes in the response distribution. It's not like all questions behave in the same way. And by incorporating the multiple languages into the simulating process, we are making the assumptions, the modeling assumptions, very explicit. So that's what we did. We created that simulation module. And here's how it helped us. Because this is not the main deliverable, but it's something that helped us to achieve that main deliverable. The first thing is that we got a much better understanding of the problem. And when I say the problem, I mean the data and the model. Then, since we have functions to simulate data, it enables parameter recovery studies. So now we have data and we know the true value of the parameters that generated that data. That means we can compare posterior distributions with the true values. And on top of that, our modeling assumptions are more explicit. Remember I said the very first model we wrote was extremely simple, and we iterated and made it a little more complex one step at a time. We started with a case which is not realistic, assuming we have a single question and a set of people who speaks the same language, and all the people answer that question. Then we made it a little more complex, allowing for multiple questions. In the next step, we allowed for multiple languages. In the following step, we allowed for the adaptive design, meaning that some people are going to answer some questions and other people are going to answer other questions. And finally, we included nonlinear effects in the model, which is a characteristic of the model that makes it a little more tricky than usual. And while doing this, we arrived at the final model, but we also get a much better understanding of how the sample size, which is the number of subjects in the database, and how model complexity, which is given by the number of questions, number of languages, and the nonlinear effects, how they affect how well we can recover the parameters, in terms of bias and variance, and how they affect the performance of the model. And when I say performance, I don't only mean speed, which is important, but also memory. And now I'm going to tell you some of the tricks we used in this particular case to make the model work with MCMC in reasonable time. And do you remember, going to go back a little, these boundary parameters, these are usually called cut point parameters. They used to be specified using a built-in transformation in PyMC, which is the ordered transformation. And in this project, we figured out a clever way of specifying the priors for the cut point parameters, which still satisfied the constraint that parameters, that cut points are ordered, but it leads to a more tractable procedure, so the sampler, the sampling was faster. Another important thing we changed was the likelihood function, not because we changed the likelihood function, we are still using the same likelihood function, but we re-implemented the likelihood function in a different way, always with the goal to make it more efficient. In this case, we wrote the likelihood function from scratch, making sure we are not performing any unnecessary math operation, or that we are not allocating any array of values that's not going to be used or that can be replaced by a simple scalar. So that helps us because we are doing less mathematical operations and we are allocating less memory. And I would say that these first 2 points are very specific to this project, and they enabled us to get MCMC working in reasonable time. And then, as usual, we tune the parameters of the prior distributions. We want the priors to be not tight or restrictive, but at the same time, we don't want to have extremely wide priors because we know they affect the computational speed. And on top of that, in this case, we made the model a little more realistic. And when making the model more realistic, we ended up making it a little more complex, but at the same time, it resulted in better sampling speed. So the final model ended up being more complex than the initial model, but the sampling speed was even better. Once we had all the parameter recovery studies and all the improvements we wanted to make to the model itself, we tested different inference engines. Rewriting the model and coming up with a model, it's just a part of the work. Then here, since speed was a priority, we tested different ways of fitting the model. As usual, we get started with the default PyMC sampler, which already comes with different initialization strategies, which can be helpful in some cases. But in this particular case, it was not enough. So we tried JAX-based samplers. In PyMC version 4, the underlying model can be compiled to a JAX function, and that enables you to use other samplers, like the non-pyro sampler or the blackjack sampler. And that ended up being what we needed. Also, there's something I wanted to tell you, not because it is the solution we ended up taking, but it's something we tried, which is a cool new library called NotPy. You can find it under the PyMC organization on GitHub, and it's a sampler written in Rust. It was created by Adrian Seibold, and now it lives under PyMC. So we tried that one in this project, but it is still not mature enough for our needs. On top of trying different samplers and different strategies to use MCMC, we also used variational inference, and we compared the results obtained with MCMC and variational inference in terms of posterior, in terms of speed, and in terms of the size of the final posterior inference data. After everything was pretty much done, it was time to demonstrate that the model could actually work with real data, because with simulated data, we try to follow the real data generating process as closely as possible, but it is still a very controlled scenario. So we wanted to test the model with real data. We did that multiple times using multiple personality facets. To give you an idea of the size of the data sets used to be 3 million observations, containing 350K subjects. And that means that the model grows so much in terms of parameters. And that's where the complexity of the model comes from. You incorporate more subjects to your database, and the dimensionality of your posterior keeps growing. And we did it with MCMC sampling. And we were extremely happy because it worked. It worked very well. No divergences, no problems with the mixing of the chains. Everything went very smooth. And it fitted under reasonable time for the size of the data and the size of the model. What was the final deliverable of this project? What we ended up delivering to Alva Labs. On one hand, we have a Python module, which has one of the most important things, which is the improved model they can start using. But at the same time, while carrying out all the parameter recovery studies, we had to develop many functions to analyze the posterior, to compare posterior with simulated values, or to explore the posteriors when you use the model with real data. And so we delivered all that as well. And also all the code and the notebooks we used in the parameter recovery studies. Going from the very simple case to the most realistic one. It is not only the model, the code, and those parameter recovery studies, but since there are a couple of things that we ended up inventing for this particular project, we thought it was nice to document everything. So we ended up delivering a good amount of documentation as well in terms of the code and the math we are using. And as I already told you, the results of the parameter recovery studies, which allow us to know how well the model recovers parameters, and the applications we did using real data. As a summary, what are the results? we have a model which is more reliable, faster, more flexible, and more memory efficient than the original model. Now the new model fits in a reasonable time, in hours with MCMC. It's not days anymore, or not crashing a computer because of memory issues. But at the same time, we didn't make the model simpler. We made it more flexible. One of the good things is that with this new model, you can detect which questions are more informative. And this is important when you are selecting questions in the questionnaire. And it models the cut point parameters in a more flexible way. As I said, we use less RAM when sampling because we allocate less things. And the resulting inference data object, which is this RVs object where we store the posterior and many other things, is smaller because of our reparameterization of the model. I think that's it. I would love to answer your questions in case I haven't checked if there are questions here, but
there are definitely questions. Yes. Thank you, Tommy. That was amazing. Yeah. So I'm just going to read them to you. Oh, actually, probably you can also. Well, no, let's leave it up in case you need them. So Armin asks, could you comment on how much faster the sampler became after these steps? And related to that, Raman asks, why do you care so much about memory, not about memory in the cloud?
I'm seeing I'm not seeing the first question, but I'm seeing the second question. It's why do you care this much about memory, not enough memory in the cloud? I mean, yeah, I think you could rent more memory if you wanted, but we were developing the model in desktop computers or even laptops. So it's better if you can iterate locally and improve things locally. And then in your production setting, you can go and use the cloud. But at some point, you are developing locally. And unless you have 64, 128, or even more memory, your computer may crash. So it's good to keep it small.
And then how much faster was the model after all these changes compared to before?
So the final tests using 350K people, I think it was 20 questions. I don't remember exactly how many languages. It took 8 hours on our computer, which is a Mac Studio. And it would take, I'm not so sure, but days on Alva Labs side, or even impossible. In some cases, the sampler would not move with the previous model.
Yeah, I guess, Morgan, this is what you had mentioned, right? That sampling usually wouldn't even get off the ground. So maybe one more question from Ben. How is the trained model validated? Specifically, how do you know that person trait is useful, and how is that usefulness measured? Are you purely trying to predict answers to questions the candidate has not answered? Or is there some sort of follow-up with the customer to see how person trait correlates with success?
I'll answer that.
I think I can. Okay.
Yeah, so we use methods that are common in psychometrics, which is to relate results from our test to other tests measuring the same sort of traits. So, and the reason why this is important is that if we read a research paper that says that, for example, conscientiousness predicts job performance, then we want to be sure that our measurement is similar to the one used in the research paper. So what we did was we paid participants to complete our personality test and a test called the NEO, which is commonly used in research. And we saw that the correlations between our results, and those results were high, above 0.8 in most cases.
And another question from Jordan: how often do you rerun the model to update the parameters?
That's an excellent question. So as Tommy mentioned, we typically run these models locally, planning to move parameter estimation to the cloud, but that's not the way it is right now. I would like to do this more often, but right now it's a couple of times per year, to be completely transparent and honest.
And I guess we're right on time. There's still a couple of questions. Sorry if we didn't get to yours. Specifically, Alexander Brewer had some, I think, deeper questions, which I think are really great. So maybe, you want to connect with Morgan directly to answer that. It seems like you're also in that field. Have a meeting of the minds. So yeah, with that, well, thank you everyone for joining and for asking many questions. We hope this was interesting to you. We will post the live recording on YouTube and post that on the meetup and our other social media channels. And of course, thanks so much for Morgan and for Tommy.
Thanks everyone.
Thank you for
everybody
thank you for having
coming
me
to this.
You can find me on LinkedIn if you want to reach out, Alexander or anybody else. Search for Morgan Peel and you'll be able to find me on LinkedIn.
Fantastic. And as Morgan already mentioned, they are hiring. So if you think this work is interesting, definitely seems like a great place to work. So yeah, another great reason to reach out to Morgan if you want to do some cool PyMC modeling in an applied setting. So with that, have a great day or night, everyone, depending on where you are, and we'll see you next time.
Bye.
See you.